All right, I think we're going to go ahead and get started. Hi, everybody. My name is Chris O'Connell. I'm coming from Lockheed Martin out in the DC area. Generally speaking, I like to have very interactive conversations. So by all means, you see something weird or I want to ask me a question in the middle, by all means, I'll try to address it as they come up. Today's focus is mostly taking the Gradle build environment and taking it into a network that's not connected to the internet. I kind of came up with this talk after attending a number of different summits and sessions and conferences. And kind of the minority that's represented at these sessions are the closed network community. A lot of products assume you have connection to the internet, as most web development is on the web. But we can use a lot of these tools without having to be connected to the internet. And it just usually takes a little bit more work to get everything set up, established, downloaded. And to some level, you will have to be connected. But a lot of times, it takes a lot more transitioning from that to get onto these closed networks. So I'm going to take kind of our example, case study that I worked on. The program was initially set up such that you had, but the program I supported, the project I supported, essentially every team had their own little development environment. So like an infrastructure team, a control team, a GUI team, and they would all have interdependencies with each other. But also conversely, these were all in a shared common repo that was actually using a CVS-based approach. So one big gigantic repo where you had a file that you had to check out individually, and you better make sure your developer checks it in before they go on vacation, because now development is halted. As a result, our build process would take pretty much an entire day for it to get fully compiled and deployed. Another kind of interesting part of that was the fact that we had a number of different projects on our site that were developed in Java that had a similar architecture. So every program had their own unique culture, their own way of doing it, and in the end, they ended up doing a lot of the same work and duplicating it. So as I mentioned, we used to have one big giant, or rather each team would have a kind of control of their repo. It was a CVS-based approach. And we used a Ant to kind of manage all of our builds and infrastructure. Now, this is probably about 10 years ago when I started, and there had been no concept of Ivy. There was no concept of dependency, matrix interaction. So a lot of times, things like open source libraries, well, we just put it somewhere in our system and update the Ant to point to it. This also meant anytime a new developer came on, they would have to manually set up their Eclipse build, and we had to make sure they had the correct version of jars. And our build was initially set up to run kind of a weekly build process. So you develop essentially from Wednesday on to Tuesday, run the build on Wednesday, and deploy on Thursday. And that's the optimistic, make sure there's no problems with the build. If the build failed, you had to go in, stop everything, focus on getting that going, and then restart the process from the beginning, or rather where it failed from. And this, of course, we could be very much delayed, working long hours trying to make our deployment schedule. As I mentioned before, the developers had to also set up their Eclipse and development environment manually. So a lot of times you'd go to the senior most member of your team, initially copy up their class, the project files, and set up the Eclipse. And this became very cumbersome as we started adding more and more dependencies and started adding open source. And we found that each of the development teams had their own unique process. So if I got traded to go work on another team, I had to go relearn an entire process from start to finish. So first thing we did, so we started realizing we needed to make a lot of improvements in our process if we were going to be competitive in our market. We realized that there was a lot of similarities between the programs, as I mentioned, and we started realizing that we would need drastic changes to become a little more modern. Well, the current implementation of our revision control system, we would have had to write all these manual scripts to check out everything, to migrate everything, and completely redo the build. So we realized at the time we need a next generation revision control system. Now remember, timeline here is 10 years ago. So our options when we started were actually get an SVN. Well, not really 10 years. 10 years from when I started, plus or minus 5 years from then when this actually happened. We also realized, like I said, our jars just had their own custom built layout in terms of their class. So we just kind of threw things with our COM, LMCO, or in some cases we didn't even follow that convention. So it would be like project A dot data files dot what have you. And we realized that we wanted to have a little more structure to this so that we could have artifacts that we could share and deploy. Again, we were looking at the options out there, and we're trying to decide between Maven and Gradle. In either case, though, we did find, obviously, Gradle supports the Maven-like structure, and so we were able to proceed and get our source set up this way once we set up the Git repository. So initially, it was easily deployed on each project. So everyone, again, sort of went off, set up their environment, and now we found that developers could independently set up. All the dependencies could now be pulled from a centralized location. And I'm not going to go spend my time here talking about all the benefits of Gradle. There's a whole summit here that can discuss that. But everything that Gradle gave, we were able to pull into our system. So now we understand what we need to do. We need to modernize our repository system. We need to modernize our build system. Okay, how do we get to where we actually deploy and develop? So kind of an open framework toolset chain that you've probably seen, maybe even are familiar with. We used a Git, Garrett, Jenkins, Artifactory approach. And we had some elements that were connected to the unclassified system. And so that became our test bed of finding out everything that we needed to get this set up. So now we mirror that same exact process on a closed network, but now we have to essentially build up everything and then recheck it into the closed network. So anytime you need to download and update, you do it first on this unclassified side and then bring it on over to the classified. So another big problem we have with this, of course, open source. Now, we have obviously no control of an open source's development cycle, and honestly, a lot of the really stronger ones put out very frequent updates. And so in order for us to be able to keep up with that, we needed to have the ability to set up, have a system that could pull down these dependencies as they came up, but we also had the ability to control the versionings from getting into our project. Now, big problem with my company in general is that we have to get all of our open source versioned and approved by our customer. And it's mostly to make sure the versioning doesn't introduce a new security hole or make sure that it's been approved to work on whatever platform it's worked. It's mostly the software licensing aspect. So, so now we can pull down the latest, work in a kind of a sandbox environment, make sure everything's working while we go off and work through the legal procedures. And once that's all set and done, we can then take that and download that onto Artifactory. We also found that one of the ways to kind of ensure that all of our programs would follow the same paradigm is we started developing our own custom plugins. I'm actually going to talk a lot about what our plugins did, show you some example code of how it worked, and talk about how it was able to set up all of our closed network side. So the plugins are initially stored on, we develop everything relating to our plugins on the unclassified connected to the internet side. The thought being that every program is going to want to use this, and you have a collection of different closed networks, but we want them all to follow the same common process. And since the Gradle plugins themselves have no real knowledge or even care about the actual contents of who uses them, it was very safe to keep them on the unclassified side and allow it to be updated by our developers. All of our plugins all extend for a common base plugin that we've developed, and that base plugin sets up all the common environments and settings and variables so that if I wanted to write a new plugin, all I needed to do was extend that and continue on. So here's our base plugin. First thing we want to do is make sure that all of the projects have been set up to compile with a specific minimal Gradle version. So you can see that at the start of the apply the plugin, the extension that comes with this plugin has a method to determine the version of Gradle. So we can look up and say, oh, we're running this version of Gradle on this project. If our minimum version matches, then we go ahead and pull down and essentially allow this plugin to be applied. So to clarify, each of the Gradle plugins we had it compiled with a specific version of Gradle. And this check right here at the base plugin is to ensure that the project that we're applying it to is running the specific version of Gradle the plugin needs. Otherwise, the apply will do nothing. The base plugin is very much like this. So we initially set up, we want to ensure that all the basic, we want to set up the base plugin and its base extension and this output here. So we first set up, we say apply the base plugin. Next, we want to go ahead and create the extensions and register it with the project. And I'll get into the extensions in just a sec. We then set up some common configurations that we run for our builds. In this case, we had one called archives for some of our such. And then we also, when we have projects with C or C++ capabilities, we initialize the C and C++ common library and settings and such like that. We then set up how to pull down the repository. So one of the big challenges we had in moving to the closed network is now you have to go through and update all of your dependency lookup, your plugin lookup, to essentially look for servers that are on the closed network. And so we do this by allowing the base plugin to look for this repositories list and set that up to start looking at that. So the template that we tend to follow is the Gradle plugins will set up a lot of common boilerplate code for a program, but it also allows specific projects to override their capabilities. So it becomes a template for the rest of our projects. So in this portion, we set up the repos that are available to the project. So we found that some of our, like I said, we're running Artifactory to store all of our artifacts. Now we have artifacts that we deploy and deliver to and publish, but we also is also where we're storing local copies of our open source. And we found that a lot of the open source already had hooks and capabilities with Maven, since most of the ones that we used deployed to Maven Central. So we actually took advantage of that and kept the open source using a Maven-based Artifactory configuration. Whereas with the rest, with all of our products, we used Ivy. So now we're just saying add those repos there for those types. And we do that by saying that anything with our project, anything that we deliver will have this name of snapshot to it. So we deploy to the Artifactory repo snapshot. So it becomes libname.snapshot. And you can see we also have set up a variable for a repository host. So I'm going to talk about a little bit later how some of these variables get set up so you don't have to have every project filling in repository host, for example. Last week we set up kind of how this is going to publish into Artifactory. So we define the behavior of when we are publishing locally. And we also want to make sure that only approved users, or CIs even, can publish to Artifactory. So the check here at this line, at the third line there, is actually making sure the user isn't trying to publish without their proper credentials. We then look to see if the project has overridden the default publishing repo location in Artifactory and sets it up to that. And again, we like to put a little bit of debug to make sure this is working. We then set up the publishing information. Otherwise, if you don't have the permission set or you're overriding local, we're assuming that the publish will automatically publish locally. And lastly, we also have portions that are specific to Java. Now, this is kind of our one main critical path as we do a lot of Java development over C++. And we added a concept of a sources jar to be included as part of the archives. So now every project will inherit this task, and as part of the publish, we'll also publish the sources separately. And that comes from the fact that we have a requirement to keep our compiled source and our actual source separate. Excuse me. And then the last bit is talking about if there's any sort of war web-based interfaces to make sure you use that instead of the built-in jar type. So all these custom plugins, actually we use Gradle to construct and build the plugins themselves. And this also generates this apply.gradle file, which we can then insert into all of our projects that automatically set up the downloading and the URLs and all the variables to pull down the Gradle plugins. So here's our overall big giant apply Gradle template. So the first thing we do is we want to check our Gradle cache, make sure we haven't already downloaded the Gradle plugins we've desired. We then want to pull down, we go and set up the repository to where our Gradle plugins are stored. We keep them in a separate repo from the rest of our source, just as sort of a clean, keeping a clean house and making sure we don't inadvertently deliver it to our product. We then also set up all of the open source repositories for our project. And then we lastly add the local repository. So this is a common build script that's set up at the start of every project. And actually, I just realized I told you the wrong thing. This is actually the apply Gradle template. So we have a process in our Gradle build that will take this template and then generate an apply script. So this is essentially going to, the template here is going to use I believe it's called the ant substitution. So we're going to say, here are all the individual Gradle plugins that we've written, and that will add those pretty dynamically to our apply template, our apply script. So basically say, here are the plugins that are available to each of our projects. We then add a nice little debug task just to make sure that's working. Just show me everything that's available. If we run this at the root level of where our Gradle plugins are stored, it'll list them all the projects and with descriptions. So last part of that is the Gradle plugins build itself has this generate apply scripts task. So taking that template, it's going to fill out all of the available plugins by looking at its sub-projects. So we've defined every one of our Gradle plugins as a sub-project for our overall project build. We then will make sure that we're keeping track of the versioning. As we introduce new capabilities and update our Gradle plugins, we want to make sure we don't introduce any new issues. So we allow users of our project to specify the specific version of the Gradle plugins, as we call them, to use. And then lastly, we set up any additional dependencies that it needs to build. And then again, that'll be set up by the individual sub-projects. So for us, on our classified side, this is kind of our hierarchy of a simple Java project. So very much a Maven setup. Obviously, we have our source main Java, source test Java, our build Gradle. We also have this concept of the build script resolver. So that apply template is used to help generate the build script. But we want to also have the ability to define the build script and override it. So by default, like I said, it'll pull it down, download it, and copy it into its local build directory, and then run that build script. But if you wanted to debug that and put your own build script, the build script resolver has hooks in there to allow for that, and we'll get into that in just a second. We also, of course, have our common Gradles properties, and we've also set up a versions Gradle just as a quick little way to list out all the specific versions of our files. The reason we do that, most of the time when we're in development, we just leave it open-ended. We say, give us the latest of each of the libraries. But when we get to a deployment phase, we need to clamp down and say, this is the exact version you deploy with. So having that isolated to a simple file allows us to track when those versions have changed and minimize the overall changes to our repository. So to apply our build script, very first thing we do is apply the build script by running the build script resolver. Most of our projects use, again, the Java and Eclipse. We're still in the Eclipse house, so we do mostly do that. And we apply whatever custom plugins we want at that point. Once the build script resolver has resolved, we are now able to use our custom plugins by using that part there. And then the last part is just applying the versions Gradle. And what that'll do is that'll set up a mapping of the, of the individual name of the library with the version, and will also pull those dependencies down. So the build script resolver allows you to first override it by setting an environment variable. And again, we work in a Linux-based environment, so this should work pretty much on any Linux-based architecture, or Unix-based. So we define an environment variable to say that's where the build script should use. Option 2, we then see is have we overridden with a Gradle property. So if it's applied locally, we just apply it and run it. If it's a, excuse me, if we've set it with a property or an environment variable, we just apply it right then and there. We then also allow you to set a property to point to an archive. So when we generate our build script, when we package up our Gradle plugins and bring them over to the classified system, we have them in a big giant zip file. And so this will let you point and give it a specific URL to the specific version of that file and pull it down. And then the last part, again, we can just also, similar syntax, but now we can just say apply just the URL. And if all else fails, we'll say, hey, we couldn't apply it because we couldn't find the script. In which case, then we'd look at it and try to resolve it. So this exact build script resolver is stored within our unclassified repo, but is copied and applied to every project. So essentially, we have this exact same file copied in multiple Git repositories. One of the things I would like to see if we can do, and I'm very interested in at the summit, is figuring out a way to keep that common and stored in one location so we don't have to keep copying and pasting this every time we introduce a new project. Ooh. We will talk about this. It's awesome. Yeah, and definitely a lot of this, as I'm finding out from the summit, we started developing this essentially, like I said, 10 years we've been on. I've been on the program. About 5 or 6 years ago, we started moving towards Gradle, and we've been sort of behind on versions. So right now we're, I think, only up to like 2.7 as our Gradle version. So we're evaluating when we should jump next and other capabilities. So then the versions at Gradle, we just list out a nice big map of the library we want to use with its full path to the metadata and its version number. And then we just have this nice little iteration over it to set up our dependencies. Last thing I'll say is I've been very sort of optimistic when I say every project's like this. Every project isn't quite like this yet. This is our end goal, is to have this kind of common template. And definitely as we move forward, we're going to try to approach Gradle and try to come up with some better ways of making sure we have this common framework. So our overall documented report process right now, so we keep all of our source up on repo. We then push to our local, every developer has their local workspace that they develop on. And then we have our binary repository to store everything. So this is sort of the interaction we have now. Moving forward, we are looking into things such as we have a concept of monolithic build. So we will have a single project that all he does is check out every one of our repos and kicks off a Gradle on each of them. Right now, it's an incremental build, and we haven't fully taken advantage of its parallelization capabilities. But I'm hoping with things like composite builds that might be a solution moving forward. Any questions, comments? Sure. We have a little bit of both. So initially, like I said, we had like a single repository that had like all of our source in it. And so one of the things we tried to do was pull those apart. And in one instance, what we did, we actually created multiple projects within that same repo. But in some cases, we just flat out created new repos and had a single project build for that. So even with this process, we've been able to support both multi-build and single build. Did you have a question? Yes. We watched it burn. We watched it burn, yes. I think we initially tried doing that, and we had one particular project that was also responsible for setting up configuration, and that configuration changed based on where you were deploying to, where you were compiling on. It was very dynamic and chaotic, and the Ant script was very, very large. And that one, I think it was just easier to kind of scorch earth it a little bit. No, once we kind of restructured our code, we actually found there was really no reason to call the Ant anymore. So I think it was more of a, okay, well, let's try to get it ported over to Git. And now the code's in there, now let's try to organize it. Okay, well, now let's have Gradle call Ant. Oh, wait a minute, we're actually now set up in a very Maven-like framework. Why not just have Gradle call it directly? We've also had to set up some customizations and other things, but for the most part, we are using Gradle straight up. There were, again, so we had our own, we had all the initial projects, and we had sort of a federation of projects kind of get together and decide they were going to do this one approach. We definitely had other programs within our location that had looked into Maven, and I believe at the initial evaluation period, we had compared Git and Maven side by side. I unfortunately was not on the deciding factor on that, so I'm not sure what led to us finally getting to Gradle. I think overall, I think there was just more flexibility in terms of the dependency management, in terms of some of the custom environments. I actually don't mind Maven. I actually kind of like it. My only concern is that it is you have to do it this way, and that's the way it's done. Gradle, I feel, gives you, and actually, to be perfectly honest, part of what led to it was, with Maven, you have to set it up in that, source main and the whole hierarchy. And initially, we weren't even going to do that. So we were looking at Gradle as, oh, well, we'll just tell Gradle to set it up to our custom build and it'll just work. And then I don't even know what was the deciding factor, but it was just suddenly, oh, well, why don't we just restructure it while we're in here? So it's a lot of, we're going to move forward slightly and then back away, but then move forward again. So I think it was just a lot of trial and error getting to the point that we're at now. The plugins out of the source build? Oh. Not for our production build. I've written some tasks that I've thrown in there to kind of help with some of the common such, but it just came down to kind of a scalability for us. That we just wanted to have, here's a central location, here's a common set of tasks, let's just set them up off in its own little world, and we can just pull them in as needed. I do also think we're still learning all the little nuances of it, and we may not have even realized that was a thing until recently. Well, and what we were trying to do was kind of, do less of the copying, but we still wanted to not have to do we were trying to avoid a kind of an unmaintainability kind of problem. So I think we initially looked at that and saw that if we did that and we wanted to now update our version of Gradle, we now have to manually go to each repo, find that specific file and change it. Whereas we have a single location, a single file, and it's just, okay, copy that everywhere. I know I'm sort of splitting hairs a little bit because you could do that with the source, but that was sort of the decision that we came across. Hey. We've
Because like we have built the Netflix, and the funniest story we had is somebody contacted us about a build idea, and literally every line in the build output was a deprecating point, telling them exactly why their build was failing, and we can't align them. So our solution to that was make them link violations and give them an automatic task that they're build up.
wow.
So we do that for plugin relocations, we do that for unused dependencies, we do it for duplicating classes, all of the really common problem we're going to do.
Yeah, there'll definitely be something I think would want to talk about because yeah, we're still fighting issues like again, multiple dependencies, transitive dependencies are hurting us in some of our programs right now. We've managed to go through and just say don't set it to false on our build script. And again, moving forward, we're a company that's moving towards using more open source products and actually contributing back to that community. So we're more in favor of doing the technology, and our overall process of getting that has improved. So yeah, definitely if there's new technology that's out there, I want to explore that and try to bring that in. So let me help you and you can help me. All right, well, if there's no other questions, I think that'll be it. Thank you very much for attending, and thank you for being somewhat conscious after lunch. If you have any questions, my email's at the start of the slides, and like I said, we'll be in contact, I guess. Thank you.